go over a few just algebra basics and how maybe it applies to physics, although this isn't a physics problem necessarily. But this is the equation. If you have a circle like I have over here to the right, if you have a circle inscribed inside of a triangle with sides A, B, C, and you're thinking, what's S? Well, S is A plus B plus C divided by 2. Now, A, B, and C would all be in a distance, so meters, centimeters, millimeters. We can say centimeters in this case. Something I do want to point out, this is a square root symbol, which we call a radical in math. And if you wanted to solve for something under this radical, what you would have to do is you would have to square everything. So if you square everything, if I get my R to work here, then that'd be R squared. Well, when I square a radical, it goes away completely. So then I would have S minus A times S minus B times S minus C, all divided by S. So, but this is actually a question in your book on page 29. It's number 26. So page 29, number 6. And you will see the radical in physics quite often, and you do have to take the square root if you want to solve for something under the radical. But in this case, they're just asking, is this dimensionally correct? That means R is the radius, I didn't bring that up. R is the radius of the circle. That'd be from the center to the outside. We call that radius. 2 times radius is the diameter. And so that would also be in a distance. So if A, B, and C are in centimeters, R should be in centimeters. So they're asking, if I do all of this mathematics inside here, do I get a distance out here that's consistent? Well, you can only add like distances or like values. So in other words, I couldn't say centimeters plus time, but A, B, and C are all centimeters. So if I add all those together and divide by 2, S is going to be in centimeters, right? And then A is already, we determined all these are in centimeters already. Centimeters, centimeter, and centimeter. Well, centimeter minus centimeter gives me centimeter. So centimeter minus centimeter gives me centimeter. Centimeter minus centimeter gives me centimeter. So those all give me centimeters. Now, centimeter times centimeter times centimeter gives me centimeters cubed. And then we've already determined that S is in centimeters. So when I divide those, centimeters cubed over centimeters, that would be just like centimeter times centimeter times centimeter over centimeter. One of the centimeters divides out, and I'm left with centimeter squared, which if I have the radical, I take the square root and I get centimeters, or if I don't have the radical, I have R squared here, which would be centimeter squared. So yes, that works out dimensionally correct. It sure does.